Happy Monday, everybody. How's it going?
Hey, happy Monday.
Good to meet you,
Happy
Colleen.
Monday.
Great to meet you
How
guys.
was your weekend?
It was good. It was hot here, but it was nice. We did a lot of outside stuff. So that was good.
Outside stuff. That's cool.
Yeah, like the kids, spraying them down with a hose, that kind of thing.
Hmm. Sounds fun.
Yeah. What
That's
about you?
interesting. Mine was pretty low key. I spent the weekend reading about the history of ERDs. Peter Chen, who wrote them in 1976, I believe. So, it was exciting. Yeah,
Cool.
yeah.
I
Matt?
spent the weekend doing family stuff and creating YouTube videos. So, yeah.
Love it.
So,
I
real
love it.
dynamic bunch here.
That's right. That's right.
It's kind
I
of
know,
funny.
I
Before
feel
the,
like
Go
I
ahead.
feel like we should
before
have
we
been like,
went,
oh, I hiked El Capitan or something, but no,
Yeah,
I sprayed my kids
well.
with a hose. It was great.
as before we started the show, I thought it was interesting. You all have, you all potentially could have crossed paths actually almost 20 years ago.
Yeah.
I mean, I
Yeah.
think we did. We just don't
Yeah.
remember. Yeah, we know a lot of the same people from UC Santa
Mhm.
Barbara from 20 years ago.
Yeah, we were there
So,
at the same time. We overlapped for 2 or 3 full years. And so, yeah, and both of us have degrees signed by Arnold Schwarzenegger, which is pretty cool, right?
Oh, well, I don't because
Oh, you don't?
no, you're right. He would have signed my master's degree.
Yeah,
Okay. Okay.
yeah, there you
Yeah, I got to go dig out the certificate.
go.
Oh, yeah, because Arnold was
mine's,
governor back
mine's
then,
up here
huh?
on the wall. But yeah, yeah, we were both in the physics department at UC Santa Barbara at the same time. So we know
That's
a lot of the
crazy.
same people. Go Gauchos.
Go Gauchos indeed. Yeah. Tell us a bit about Starburst Galaxies, by the way. It has a bit
Oh,
to do with your
well.
current job, I guess, kind of, peripherally.
Yes. So, I thought you wanted me to talk about Starburst Data, but I can also talk about Starburst Galaxies.
Either one.
Yeah, so Starburst Galaxies are really cool because, I always like to say, look at the Hubble images, but now you can look at the Webb images, which is even better. But it looks like there's empty space in between all the galaxies, but it's not, right? Like there's actually stuff there. It's just not visible to the naked eye or, to visible light. But there's a lot of material in between the galaxies, and it gets kicked out by these powerful collisions between galaxies. And so when galaxies collide, you've got gas and dust colliding, and then that kind of mixes together, and then gravity helps it along, and it turns into what we call a starburst, which is like, tens of thousands to millions of stars basically being born at the same time in what we call a stellar nursery. And then if you fast forward several million years or several billion years, actually, they explode around the same time. And so you get this burst of light. And so you can actually use that sort of as a beacon. Like if you think about a lighthouse, you can use it as the background light source to study everything between you and that galaxy. So you can look at absorption by certain things, or you can look at emission of the galaxy itself and tell a lot about the space between you and the starbursts. So it's pretty interesting.
Now, when you say explode, are we talking like supernovae here,
Yep.
or is this some other? Oh, wow,
Yep.
that's
Yep.
really cool, actually.
Yeah, it's pretty cool. So, yeah, and I mean, it's really fascinating being able to do that. And so, they're very bright, and you can predict how bright they are. And stars, when they go supernovae, have like a very distinct light curve that they follow, and like brightness curve that they follow. And so using that information, you can actually tell a lot about the galaxy itself, and you can tell a lot about the intergalactic medium between you and the galaxy.
And this is why we have elements beyond iron, right?
Yeah,
On Earth,
yeah,
because of
all created
super-
in supernovae.
Wow.
Yep.
We could really, really nerd out here, Joe. Maybe you
I
should
know.
write
Can we
us
just do
more.
this for an hour?
Monday morning physics chat.
That's
I'll just
I love
sit
it.
quietly in the background.
Well, and it's funny because most of the physicists that Matt and I know from
Yeah.
UCSB are now in data, because what did we
Really?
do? We were just looking at data, like especially in experimental physics. That's all I was doing, was taking giant data sets from telescopes and cleaning them and combining them and then slicing and dicing them to tell a story. So instead of telling a story about a business, I was telling a story about the universe.
And I don't. Have you ever met Josh Starmer? Do you know who he is? So he does a lot of stats content.
Yeah, I
on
saw
YouTube.
your show with him. Yeah.
Oh, okay, awesome. Yeah, so we were kind of talking about the same thing, and I told him, like, I've never actually taken a stats class, but like between quantum mechanics, thermodynamics, like you do lots and lots of statistics in physics, and of course, if you're doing experimental work, you collect a lot of data.
Yeah.
And data fundamentals don't change that much whether you're using. And Joe, you say this a lot, but whether you're using Excel or databases, the basic principles are the same.
Yeah.
Should be.
Yeah.
Yeah. Well, I mean, the thing is, it comes down to the same points. It's data quality, it's data volume, it's how things change over time. I mean, it's all really the same when you think about it. It's just, you also get like a pretty picture of a galaxy or something along the way instead of, a scatter plot that tells you number of customers over time or something. So.
Well, sorry, my dog is
Your dog does not enjoy this conversation. I'm sorry to say. Oh,
maybe she does.
She just got shots at the vet just a bit ago, so she's probably about to start being a bit loopy in a second. So.
Oh, fun.
Anyway, yeah, carry on. It's a great.
Well, I'm a bit curious. I mean, I'm always curious how people make this journey from getting a PhD in the sciences somewhere to being in data and then being, head of engineering as well.
Yeah. Well, I always like to, I jokingly tell this story whenever I talk to like grad students who are looking at how do you get a career in data. My one thing that I always said, even to my parents, I was like, I never want to go into software. And that was my number one thing. So, clearly I was not good at predicting my career path. But the reason I didn't want to go into software was because I didn't enjoy coding as much as the other aspects. I enjoyed presenting data. I enjoyed, the analytics of it, but I didn't want to, I didn't know what software was, right? Like I was in academia, I was living in the academic bubble. I didn't understand all the different aspects there are to software engineering and software development. And so for me, data engineering wasn't a thing at the time, but like what I wanted to do, you could have described as data engineering and analytics. And so for me, it just wasn't what I was looking for. And so when, I got a cold call from a recruiter and, I had traveled until money ran out after grad school and I didn't know what I wanted to do. And so, I went to lunch with this recruiter, convinced me to talk to these people, and ended up working at Ab Initio for 7 years doing ETL development and consulting and training and support. And I really, I learned about software development, which was great. And I got to do a lot of different things at Ab Initio, which it was the era of big data and everybody was trying to harness big data and do stuff with it. But before they did stuff with it, they had to harness it. And so that was sort of the era of, MPP processing and all that stuff coming to life, which was exciting. And then I sort of wanted to see where people went with it and like what they did with it. So I went more into the analytics and data science space, but I kept coming back to the data because the data quality and the data volume and, the data curation was always the problem. Right. And I think it still is like, people, this is, say 2014 when everyone was like, we need ML, we need AI. And it was like a buzzword and they didn't know what they were talking about. And it was like, you don't have the data to do that. And you actually don't really always have the use cases. And there were some companies that were doing it well, but for the most part, enterprises struggled with that. And so I went back into the data space and I started leading data and analytics teams and building them from scratch. And I had done that at a few different places. And so at that point, I'd sort of, built data lakes, built centralized data warehouses, built central data teams, and really started feeling the pain that a lot of people feel when you scale up. So, sort of building that, what we now call the modern data stack, where you're, you've got some source data, you're ELTing or ETLing it into a data warehouse, curating it, and then putting a BI layer on top of it. And, that was really challenging because of all the reasons people find as you scale up. And so for me, I started thinking about, how do we fix this? Like, I didn't want another job where I was, picking a different tool set, but doing the same thing over and over again. And so when the opportunity came up at Starburst, I actually started talking to them because I was more interested in Starburst Galaxies, but I had heard of Presto Neutrino. And so I was really interested in that. And so here we are.
Did you get confused? Were you like, Starburst, this obviously fits with my PhD. Then you show up to the company and you're like, oh, never mind.
Yeah.
I'll talk to you anyway.
Well, it's funny because when we were naming Starburst Galaxy, our SaaS offering, I was like, it has to be Galaxy. It has to be Galaxy. And, there were some other names we kicked around, but, I was really excited when the marketing was like, yeah, we're going to call it Galaxy.
Well, I mean, they better take a name suggestion from somebody of your caliber.
Yeah.
Well, we do
Yeah.
joke, I actually joke with our CMO sometimes because she'll come to me. She'll be like, I need a name for this thing. And I'm like, here's 47 names. And most of them are way too nerdy, but sometimes we hit on one. So we joke that I'm going to be the chief space themed naming officer. So that's my new career.
You've moved into marketing, basically.
Yeah, totally.
I'd be the one asking the dumb questions, like what's Captain Kirk like to hang out with?
So he sat behind me. Okay, this is my Patrick, not Patrick Stewart. What's his name? William Shatner story. He sat behind me on a plane once. I was 8 months pregnant, and he shoved me out of the way to get off the plane first.
Whoa!
And I was
Kirk.
like, "Did this just happen?" It's just like, what just happened? Anyway, I don't have a lot of love for him, but I'm sure he had to go to the bathroom or something. So, yeah.
Interesting.
Anyway. Yeah.
What was that? That thing in Star Trek, the game that was impossible to win. Anyway.
Kobayashi Maru.
Yeah, that was it. Yeah, maybe he was just that's how he won, just that attitude, just very cavalier, like out of my way.
Yeah.
Rules,
he had to go get
rules.
some Priceline deals or something. Yeah. But it was a good. I was like, did this just happen? What is going on? So.
Wow.
Yeah. Good times.
I'll make sure to sit behind him.
Still get in his way. He's got things.
Yeah. So he doesn't actually fly a spaceship. Okay, never mind. That was my question.
Not that day.
So. Not that day. Yeah.
He just flies in a plane like a normal person.
Yeah.
That's cool.
Yeah.
Well, one of the things we think we wanted to hit on, we're talking yesterday, data mesh in the modern data stack, right? These are two things, possibly two buzzwords, but we'll call it what it is. They are. There are things in this world right now. So, but you had some interesting thoughts on how these two interplay. Do you want to walk us through that?
Yeah. So in my mind, and this was another LinkedIn conversation we were having with Ben Rojigan, the Seattle data guy, about, what makes a modern data stack, right? And I don't think that the modern data stack is particularly modern. It's basically a reimagined cloud-based managed service version of what we've been doing for 40 years.
Well, it's 10 years old at least. Yeah.
I mean,
it's
older than that if you go back to like mainframes and early days of Teradata, right? So
like 1980s, 70s.
And so I've been thinking about that for a while, but I think the modern data stack, the beauty of it is really simple to get up and running with a data environment with like minimal humans and minimal expertise, which I think is great, right? Like you can spin up something with like, an ETL or ELT tool and then some cloud-based data warehouse. And, you can start doing analytics fairly quickly. I think I saw someone spun one up in like a day, right? And that's great. And the problem is there's not a lot of optionality in that. And you end up getting stuck with whatever you start with. And I've worked at companies where we've been like, stuck with an infrastructure, and it's really hard to move off what your initial choices are. And it doesn't scale particularly well, both from a performance standpoint, but also from a cost standpoint. And so you end up with a lot of complexity as your complexity of your business grows. And, the difference from when you were a 10-person startup to when you're a 1,000-person, Series E or whatever, you don't have the same needs, but now you're stuck with this infrastructure. You're stuck with these tools that you've really locked yourself into. And so my thought is that, a truly modern data stack would have more optionality built in, and it would focus on things like, simplicity, scalability, SQL, because I think we all just need to admit that SQL is the way, right? And then also just speed. So like just making sure it scales and it's performant.
So the 4 S's of data?
The 4 S's. I know. I tried to coin that at one point. I don't know. But it makes it easier for me to remember. So.
Well, attach some kind of physics name to it and then it will stick.
Yeah.
Come up with something.
Oh, that's a good one. I should do that.
You should totally do that. Yeah.
Yeah. Like we'll call them like top, bottom, charm, and whatever the other quirks are. That's a joke for Matt. That's a nerd joke.
Yeah. That's too much fun.
Sorry, Joe.
That's good. I mean, yeah, I did take a few physics classes back in my day, but not like y'all. So, what was the last S? Simplicity,
speed, simplicity, scalability, and SQL. Yeah. So
SQL.
Speed.
Spin.
Yeah, and so I think that there's a lot of different aspects to each of those, but I think so that's sort of my take on the modern data stack, is that we need to actually modernize it a bit. And I think tools like Starburst can be good for that. But like, I love the plug and play nature of it. Like if you're like, oh, we need an observability tool, you can plug in Monte Carlo on top of all these other things. And some of those tools have been good about understanding both the startup and sort of enterprise large scale use cases. Like SelectStar, I think you spoke to Shinji Kim, like they have an enterprise offering, and I think they're building out a SaaS offering as well for Lineage. But I do think that a lot of these tools are focusing on that smaller use case without understanding really where do we go at an enterprise scale, and how do we scale and keep the performance and keep the simplicity in that data stack. So
it's interesting.
Yeah.
The other critique I hear frequently of the modern data stack, I think, is more of a human problem, right? Mm-hmm. So I hear people complaining a lot about like, oh, the modern data stack, it's not secure and it's really haphazard, and people are just throwing tables and data everywhere, and there's massive data sprawl, and it's just a bunch of tables. And I'm like, well, it's not really a technology problem, is it?
Well, I mean, you could say the same thing about Excel, right? And I see some of these, but I see some of these arguments about like, oh, it like contributes to massive amounts of waste and stuff. And it's like, that's more of a process issue at the end of the day. Like I don't see anyone blaming Microsoft for like the ills of the Office, right? Even though 80% plus of Excel files have errors in them and all that stuff. True. So but it's interesting. I got some questions here actually. Okay, so before we started talking about data mesh, explain to the audience what data mesh is. I think that I see the term floating around a lot. I think all of us, we know Zhamak, we know the canonical definitions, we've read the book, but that said, even though there's a book out there now, and this has been out for a couple of years, I still see some confusion. So what is data mesh?
So the way I like to think about data mesh is, so I have worked at organizations where there are centralized data teams. And one of the biggest problems I've had is that the people who are producing the data are not tasked with making sure the data is usable by the end users who are actually trying to make the company data driven, right? They're software engineers creating some product and they're like, that's not our goal. That's not in our charter. I don't care. If you want my data, here's a link to a bucket, but that's it, right? And so there's no real ownership of the data as a product. And so in my mind, the big thing that data mesh does is it helps you organize people and technology around the idea of treating data as a first-class product, really. And then everything else falls out from that. So yes, there is a lot of theory and, sort of almost academic discussion around data mesh and like, what are the tenets and like, does this mean, what does this thing mean and what should the ports look like and things like that. But honestly, it's in my mind all about treating data as a product and having curated data sets that are available to downstream users that are owned by the people who are creating the data. And the people who know the data best are the ones creating it and curating it. And so I think that's what we miss when we end up with these centralized data teams, is that you've got people throwing data over the fence. You've got one team trying to curate data from across an organization. It's just impossible as you scale. It just doesn't scale. And you end up with this centralized data team that's just a huge bottleneck. And it doesn't work, right? So I think that at enterprise scales, you end up with, lots of different data stacks, and then you're all trying to push the data into one centralized place, and that's just not going to work. And so I think data mesh tries to solve that problem with its 4 tenets of, domain ownership, meaning the people who create the data own the data and treat it like a product, right? Their charter includes creating data products, data as a product being the second tenet. And then there's 2 tenets that get a little less love, but I think are equally important. One around self-service so infrastructure, like making sure that the infrastructure is owned by the right people, right? So like a self-service data infrastructure, so that your people who are creating these data sets don't also need to be data infrastructure experts. And then governance, making sure that the governance is federated and that the people who are making the governance rules are the right people, but the people who are consuming those rules are the right people, and that it's all automated wherever possible. So that's really a very large nutshell, but that's data mesh in a nutshell.
Right, but it's not like a technology or
Mm-mm.
any specific. Yeah, and I think that's part of the
No.
confusion that I see.
Yeah.
Right, and so it's yeah, yeah.
Yeah. But it talks about the people too, which is what differentiates
Hmm.
it from other data management paradigms. And I think at scale, that's so important, right? Like you can't
Yeah.
just ignore the organizational aspects of it. And people talk about data driven cultures and data literacy, and it's like, right, but if the people who are producing the data aren't caring about the data as a product, then it's still never going to work. So
Right, like the word I see thrown around now is socio-technical.
yeah.
To describe. I think
Hmm.
it's like pretty
Yeah.
accurate. So
Yeah.
that's
That's a good
interesting.
word for it. Yeah.
Socio-technical.
It's a good word to say too.
It's not a tongue twister at all. Got a
But
couple questions here from the audience. Oh, what were you gonna say?
oh, I was just going to say, so that's why we wrote Data Mesh for Dummies, is that, Zhamak's book explains everything in detail, but I think, my colleagues and I at Starburst are just fascinated by this. We've all come from different areas. One of my co-authors is a former CDO, one is in partners. Oh, there it is. Look at that. And the idea is that we wanted to just break it down to its core tenets and just really explain what it is on a much higher level without getting into all the nitty gritty, because Zhamak has already done that. She has an amazing book. And, we really love that book, but it's also very large. It's very, very technical. And so, this is just a higher level summary of what data mesh is.
Oh, this is super helpful. Yeah. Because up to
Yeah.
now, I didn't even know this was available. Congrats on writing it, by the way. But the challenge has always been, okay, so people want to know about data mesh, and I just go read her book. I mean, I don't know what other advice to give you, except now
Yeah.
there's a Cliff Notes version of it. Now you can go read that too. So,
Yeah.
but yeah, because again, I was a bit peeved at somebody last week about this because they were like, oh, well, I can't understand how Zhamak defines data mesh, so therefore I'm going to start making up my own interpretation of it. And I was like, I mean, if you can't understand like a mathematical concept or a physics concept, do you just suddenly like make your own interpretation of what that should be? Probably
No.
not. I mean, you probably want to dig into the atomic. People were complaining, oh, I don't understand what quanta means with respect to software architecture. I was like, if you take the time to study software architecture, like quanta has been used as a term has been used for a
Yeah.
long time. So it's not my fault that you can't, and it's not Zhamak's fault either that you can't,
Yeah.
figure this out. I mean, if you just take a quick Google search, the words are out there. So
Yeah.
I was a bit peeved and very unsympathetic to these people saying, "Oh, well, it's so confusing, so I'm just going to make up my own interpretation of it," which was so far off the mark. It was ridiculous. So
Yeah. But I mean, I think the reason data mesh strikes a chord though is because it is trying to solve problems that we've all felt, right? And so I
right,
think that, you know, the interesting thing is when you have a modern data stack, that's great when you're a small company, right? And I think that it really is wonderful if you're trying to do data for the first time at your company. The problem is, fast forward 5 years, you might want a data mesh, right? So you might be experiencing those problems. So, like, how do you get from the modern data stack to the data mesh? And that's what I've been thinking about a
mm,
lot lately. And I don't have the answer, but, and I think that optionality when you look at the modern data stack is really key to that, though, because you don't want to get locked into a technology that doesn't scale. And so that's why I think focusing on things like SQL as your base language is really important.
well, I
Yeah,
mean, we
it's.
talked to. Oh, what was that, Matt?
Oh, I was just gonna say. I mean, I think sometimes that gets a lot of pushback, but I tell people like, look, it's not use SQL where you can use SQL. Sometimes you're going to need PySpark. Sometimes you're going to need something else. But what we quite often see is that people equate sophisticated data with a language besides other than SQL. Like, oh, if I'm using SQL, it's not sophisticated. It's like, well, I'm looking at your code, and everything you're doing here would be easier to do in SQL.
Yeah.
So why are you using
Yeah.
this tool?
Well, in our chat with Bill Inman, I mean, he said the data mesh and data warehousing are they're compatible with each other. It's not like these
Yeah.
are two separate things. So
Yeah. Yeah. I
um,
mean, the question is, how do you get from one to the other? And I think, like I said, data mesh is striking a chord because it is trying to solve a lot of the problems and it isn't ignoring the people aspect of it,
Yeah.
right? Like, I think that's why it's really popular right now. And I mean, I think we're at this really interesting phase where people have decided they're going to do it. And we're looking at these large enterprises that are implementing it, and some more successfully than others, and some defining data mesh slightly differently. But the key is data as a product. And I think that's what's really interesting, is that people are finally giving data the due it deserves, right?
mm.
Yeah, I mean, we've seen a lot of shout outs on Twitter and other places about some of our comments in the book about this disconnect between software teams and data teams, and that's exactly what data mesh is meant to solve, right?
Mhm.
It's making software teams not just responsible for their application, but for the downstream analytics use cases. And
Yeah.
so I think this has been a recognized problem since there's been software basically generating data. So at least since the 1980s. And
Mhm.
part of what's happened now is that it's not just a technology problem, but technology does matter in this space. This was much harder to do when you just had like a single unified MPP system and people were fighting for resources. And now that you're in the cloud and you can have separate, data domains and data processing, it's way easier than it used to be if you can solve the human problems on top of that.
Yeah, absolutely. Because now we've got so many more people because we've got so much more data. But yeah, I mean, yeah, and as you mentioned though, like I do think that a lot of the paradigm that we see with the modern data stack, getting back to my initial point, is that
Yeah.
it's based on this legacy pattern
Mm-hmm.
of there's our transactional system can't handle analytics, right? That was a hardware problem, right? Like, and so you had to move the data somewhere else into some hardware that was focused on analytics, like Teradata, for example. And so it's like, that's not an issue anymore. Right? Like, let's just use object storage for everything, or let's use Postgres for everything. But like the hardware isn't an issue anymore, right? The cloud is magic. So let's start questioning those paradigms, maybe leave the data where it is and stop moving it around as much, because that'll focus on the simplicity of the problem, right? Like the complexity that comes with trying to manage pipelines is just a lot. So the fewer pipelines you can have, the better.
Mm-hmm. But it's interesting because when you start getting outside of different domains, like domain A to domain B, I suppose it's sort of the notion of microservices. Like, would you really care at the end of the day what domain A or B does, as long as you're getting the data product that you need?
Yeah.
So
Yeah, and I mean, I think if domain A and domain B are producing data products,
yep.
then they can be well governed too, and that's
Mm-hmm.
where the governance really comes
Yeah,
in
the underlying
as
governance
well.
though. Mm-hmm. Yep.
Yeah, because like governance isn't going to matter at a small startup, right? Like no one cares, and it's probably
No.
private and it's fine. But like at some huge enterprise company or in a bank or government or something, you're going to end up with like a lot of regulations and compliance that you need to worry about, and so the governance comes in handy there. But treating the data like a product will help you with that governance, because it'll sort of organize things for you. Yeah.
That's interesting. Go through some questions here. Got a lot of questions actually.
Oh boy.
Let me see. Actually, this is a softball for you, and it's meant to be, I think, maybe illustrative of the types of questions that we see a lot. Lakehouse versus data mesh. Which ones to choose, when, and why?
So I think that there is a place for each of them. I think Lakehouse is more of an architecture question, whereas data mesh is more of an overall data management strategy question. So Lakehouse is more, are you curating data on read or on write? Right. And so like if you're curating it on read, then that's more of a Lakehouse question. And I think that I've actually been talking to one of my colleagues about this, like how do these two play off each other? We haven't like landed on an official Starburst answer yet, or official answer, and then writing a Starburst blog about it yet. But I do think that there's a place for each of them. Lakehouse is more about the speed of getting the data you need, and so it's more of a curation tactic, whereas data mesh is looking at like, once you've decided on these architecture questions, how are you distributing ownership of the Lakehouse and of the data in the Lakehouse across the organization. So I don't think it's an either or, but I think it can be a both.
I agree with that. I think Lakehouse is more of a way you may produce a data product, whereas data mesh is more how you distribute data products and and so forth. So
yeah, good question though.
But yeah, it is a good question. It is good. And then we got a follow up to this. How to think about data modeling and data mesh for Lakehouse architecture?
I mean, data modeling. I mean, I think that the domains should own it, and it should be part of the domain's work. And I do think that well-modeled data. I mean, my favorite store is a container store. I want to put everything in a box and have everything labeled and have everything beautiful in my house. Like if I open these drawers behind you, you'd be like, seriously, Colleen, because they're all like very well labeled and everything. That is my life. So data modeling is my jam. I love it. I think in reality, it's challenging, but I think that if you have data as a product, then like a well-modeled data product can be really useful because it can help downstream consumers really understand how the data relates to each other and how the data products relate to each other. So I think there's room for that both in a data mesh and in lakehouse architecture.
Yeah, I guess one of the central questions from an organizational standpoint would be, what about data that's kind of more common across teams where several different software teams are like accessing a central database to look up customer information?
Yeah.
Would you still have a central data team to manage some parts of your data model? And then they kind of take in all these different data domains and then create maybe curated sets or something like this for certain pieces?
I mean, you could. I wouldn't have a central data team. Like I shy away from those just because having been on them and having led them, I'm like, there's so many problems. But I do think that, and I mean, at smaller scale, you might still have one, but I do think that data modeling goes along with data quality and that it's part of data governance, right? And it's definitely a key part of any organization and that you need to understand how the data fits together. So I do think that in the federated governance model, you sort of have this cross-organizational layer of governance that has to happen. And so whether you have like a governance committee with like data product owners from each domain, that kind of thing, you could have that. But it's largely about things like entity standardization and quality standards. And so that does need to be like a federated aspect of it in both Lakehouse and Data Mesh.
Cool. Data modeling. This topic comes up a lot these days. I don't know what's in the air. It seems like it's a new thing that's old again. Sort of like the modern data stack is a new thing.
Yeah.
Does Matt look frozen, by the way? He just looks kind of I don't know.
He does look frozen to me.
Okay. Well, if he comes back, sort of like
well,
in
you were
Stranger Things
reading about ERDs this weekend. What do you think?
What's funny is, so I'm actually working on a book on data modeling right now. And so I've been going back to...
Wait, you're writing it?
I'm writing one, yeah.
Nice.
Yeah.
The
But, you know,
author
what
bug has really bit you, man.
it's a disease. So, but what's interesting is you go back to data modeling, hopefully Matt comes back in a second here. There have been lots of attempts at this over the years, like since the 50s and 60s, and probably beyond that, actually. If we talk like hieroglyphics and all this other stuff. And so, but yeah, old databases is something I've been nerding out on a lot, like Codicil and like IDS and like all these ones from the 60s. I think this is very interesting because it actually might hold the key to sort of newer ways of doing data modeling. So I feel like data modeling in itself is very ceremonial in some ways. We had Matt back in. Matt, you're back from the upside down.
Sorry.
Right.
So I I got the green screen of death on my Mac.
Oh, no.
Live streams are weird. Anyway, sorry I missed part of your answer. I'm gonna have to go back and watch it.
But you read books like Agile Data Warehouse Design, right? This is anything but agile. It takes a long time to do this stuff. And I'm like, so is there a better way to do this? Have we been thinking about data modeling wrong actually the entire time? And the techniques. It's very cumbersome. Let me tell you this. I mean, if you tried doing a data modeling exercise at your company, how long does it take?
I mean, not at Starburst. We're more like creating the software than
consuming it. But a lot of these things are like, it's
I would say like previous companies. Yeah. Like, I mean, I've had companies that I've worked with where I'm like, what's a customer? And they're like, well, who are you asking? And I'm like, how is that a possible answer to this question? Like define a customer, right? And so it's funny because like I do think there is a space for data modeling both at the database level, but then also at the organizational level, right? Like understanding and having that common vocabulary across the company is incredibly important. And I think, again, easy to do when you're a smaller company, but at scale, it's just really challenging. And so having sort of like an authoritative description of your overall logical / business data model. I mean, I think, we talk about Kimball and we talk about the logical and business and physical models and how they all need to roll up together. But Yeah, I think it's incredibly important to have that common vocabulary and common language between
Yeah, but we're
organizational.
on the same
units.
wavelength, no pun
Yeah.
intended. So it's just like, oh
Nice.
no, we're
Good
just gonna
physics
go. Yeah, so that's what I've been nerding out on a lot. It's just okay. So
Yeah.
like, are we even asking the right questions in this day and age? I think much like we have with the modern data stack. Like, is it the right question to even be asking? Is this like an
Mhm.
architecture paradigm that's worth discussing? Maybe it is, but like, what's next is I think is more kind
Yeah.
of what's been on my mind, because the star schemas, for example, right? It
Mhm.
doesn't work with streaming,
No.
right?
No.
But somehow we all gravitate towards this as like the canonical end all be all, and I just have to have a
Yeah.
hard disagree on that. But
Yeah.
obviously, and it's funny you mentioned sort of what I call a definitions layer, a federated definitions layer
Yeah.
across the the organization, and not just that, but I would say
Mhm.
across stakeholders, because now you have data sharing and everything else, and so it's something Matt and I've been talking about a lot. But anyway, I'll
Yeah.
keep mum about the rest of it, and you'll save the punchline for
Yeah.
forthcoming stuff. But
Well,
yeah.
I want to see how you start with hieroglyphics. You mentioned that, and now I'm really curious. So,
Yeah. Well,
Yeah.
that might be the secret to unlocking it all.
Does this end with you in like a pyramid somewhere?
Yeah, it's a pyramid with UFOs that come
Awesome.
down from a starburst. Just kidding. So,
Joe's a member of the Illuminati, actually.
Love it.
all right. Well, tangents with Joe. It is Monday morning, so
No, but I mean, so no, I will say that I do think data modeling, there is an organizational aspect to it that has gotten ignored over the years.
Big
And I think
time.
there's definitely a place for it that we need to start being more intentional and thoughtful about it, which I think intentionality and optionality is really what a lot of this work is about, right? Is being able to scale and being able to really like have a common vocabulary and things
Yep.
like that. So, yeah.
Yeah, it's interesting.
And I guess it becomes, in some sense, much more important if you don't have a central data team, right? In the days of central data teams, you just assume that team would take care of your data model for you.
Yeah.
And now you have to coordinate across the company and have people come together and say, okay, what is a customer? Like you
But
said.
honestly, that's what the central data team was doing anyway, right?
Yeah.
Like,
they
why
were.
would they? I mean, yeah, they were the ones going to each department and saying, what is a customer to you? And trying to make sense of it all. And then now we're just saying that's still important, but let's have all the right people in the conversation.
Yeah.
It's interesting because that approach, I think, annoyed people to no end. It's like, oh, it's the data team coming here, like riot, like run.
Oh, they're the worst. Oh God, not the data team again.
That's interesting. We had questions on Starburst, actually. What is Starburst? I don't think we actually didn't get to that. So
yeah, I think we talked about the galaxies and we forgot to talk about the company.
Yep.
So Starburst is built on open source Trino, and it's basically an analytical query engine that allows you to leave your data where it is and use SQL or your favorite connector to analyze your data wherever it lives. So if you have data on-prem and in the cloud and multiple clouds, you can use Starburst to talk to that data and join across different data sources in different locations. And it's really cool. And so what I do is I run our enterprise engineering organization. So we have two different products. We're built off of open source Trino. So most of the Trino contributors and maintainers work at Starburst. But so as that open core, we have people who work on that. And then we have our enterprise offering, which is basically like, I like to say Trino on steroids, right? Like we have all this really cool functionality on top of that. We have additional connectors. We have a built-in access control system. We have something called data products, which allows us to actually have people curate data sets and then govern them and define them and define all the metadata that goes around them. And then people can come in and consume through our UI. We have integrations with lots of different tools like dbt and Dagster and, Power BI or whatever third-party tool you use. Excuse me. And so that's sort of Starburst Enterprise. And so I'm the director of engineering running that organization. And then we also, a lot of people these days want Starburst as part of their modern data stack. And so the idea is that we want a managed and hosted offering because Trino or Starburst can be kind of a beast to manage your first time on your own. And so we have Starburst Galaxy, which is our managed and hosted offering where you can just spin up a Trino cluster basically and start talking to your data in minutes, which is really cool.
Is Starburst compatible with the modern data stack? This question came up yesterday on Ben Rogerson's
I know.
post.
And I was kind of like, I was going to respond and be like, well, sort of. So here's my thing. I think the classical definition of the modern data stack, which sounds like an oxymoron, is a centralized philosophy, right? Like it is about moving data into a CDW. And I think the companies behind CDWs love this, and they push it, and they push it as much as they can because it serves them well. But that said, like I keep stepping back and being like, why are we building these pipelines? Because I have been a data engineering manager, right? Like years ago, I was getting woken up by pager duty because pipelines were going down. And it's like horrible, right? And so it's like the coordination of all these different pipelines as you scale doesn't work. And ultimately, I don't think the modern data stack is modern. I think it's the legacy data stack, but hosted and managed on our behalf, which is cool. But I do think that a truly modern data stack would have something like Starburst in the middle or Trino, and it would have like a federated query engine where you don't need to actually move the data around. But there's more to it too, right? Like there's still that plug and play compatibility with other third-party tools that do things like observability or data quality, or plugging into your MLOps system. I think that's all really important as well. So I think that's what a truly modern data stack would be. So sort of depends how you define modern, I guess, is my short answer to a long answer.
It seems like, well, the big shift is not going to be in tooling, really, right?
Yeah.
Like we are going to see more federated query engines, but it's going to be a thought leadership shift fundamentally, which is what data mesh is all about. A lot of the same tools, but like a different approach to managing them and managing teams.
Yeah, and I think it gets back to that focus on simplicity and optionality for me. Like I just see people get stuck in these things, and they're like, "Well, we're a this shop," and it's like, why does that matter, right? Like, why does the technology matter? Like, it's all about getting value out of data. Like, I don't care what tools you use to do it. Obviously,
you see the same thing in engineering, though. Like you have front end teams or React or Vue teams and shops, and so it's just I think you want I think you want to be tribal with your tools, or people want to be tribal. It's like
fair.
I'm part of this group, and y'all can.
Yeah. I think they're to a point though. When tools become limited or they don't scale well, that's when you have to start really questioning like where you're going to go. And I think it's a challenge because when you are running a modern data stack and then you acquire a company that has a totally different data stack, like what do you do, right?
The SQL Server data stack. Yeah.
It sounds like you said SQL Server data.
Sorry, Colleen.
Hurts me.
This is a family show, Joe.
Sorry.
So, I mean, I think there's, and then you acquire a third company and they have something totally different. And it's like, and that's how, I start to really question the scalability and like, what are you choosing going forward from that point? And like, should it just be the thing that you've loved all along at the main company? Like maybe, but I think you need to really understand growth and have that growth mindset and really understand, we could get 10 times as big. And if we're going to 10x and our data 100x's, like, what do we do? And so maybe the tools that serve you well when you're smaller don't serve as well when you're larger.
As you talk about scaling too, one comment I would have is that it seems like the big scaling problems we have now are more to do with managing complexity than data size. Like, there's so many great tools that can handle quote unquote what we used to call big data. Seems like the term has gone out of fashion, but what's hard now is managing 1,000 different tables or managing 50 different data domains. And that's the new generation.
Pipelines and latency issues. And like, even at small companies, if you have like 5 pipelines, they're all on different schedules. It's like your ML team's like, where's the data set? And you're like, well, define data set, right? And so that's why data products are so key, because I believe in consumer focused data products where you're actually thinking about the downstream use cases that you have and ones that might pop up and like, what do those consumers need? And then build that. It's a product.
That's interesting. So what do you think is next over the next maybe 3 years in the data stack world?
I have started seeing people question the modern data stack, which is cool because I've also been questioning it. So I do think that, there's just been this explosion of tooling around different things. And, I think that's great because it gives people options, but I think data is not getting any smaller, right? And so I think there's definitely a world where data products become that much more important. And I think data as a first-class citizen of the business is how we get to that sort of data-driven world that we've been talking about for a long time. You know, people talk about data literacy, they talk about data teams, but I think what they're really getting at is how do we get from the data to the value, right? Like to the value, the strategic value for the business. And so shortening that path with data products, I think is really key. So that's my prediction.
Interesting. What do you think, Matt?
I think we're still working on like the pragmatic, implementation details of data mesh. In other words, the book is fantastic. I think teams are figuring out, how do I do this day to day? What capabilities do I need on my software teams that I now have a data team? But I feel like everything's in place. So we're really going to see these organizational transformations probably in the next 5 years for more like progressive companies. Others will lag behind, but that's
for sure, lag behind.
Yeah.
It's interesting. I wonder what competitive advantage the data mesh is going to bring to companies too, right? So companies that adopted microservices supposedly seen, some sort of a bump in productivity. I'm very curious, what data mesh equivalently brings. So I think it's microservices for data is how I kind of view it as well. I mean, ThoughtWorks is they came up with a lot of the microservice architectures back in the day, and it's no secret that influenced the data mesh discussion as well. So
yeah, absolutely. And I think it's increased agility too, right? Like it's increased ownership and agility, and you can't really go wrong with that, right? Like iterating to get data out to consumers faster is a good thing. And then having clear ownership around data is really the key that we're missing these days, I think, and just like a standard modern data setup. So I do think that, it's a journey. I don't think there's a clear destination. I think it's about increasing the value of data to the organization. And that's fuzzy enough, which, people are starting to be like, oh, that's not clear enough. But I think that's good because it means that it's what works for you in your organization.
Interesting. I think the danger is cargo culting data mesh. I fully expect this is going to be happening where it's like, oh, we're doing data mesh. This sort of agile was like cargo culted.
And Hadoop, right? I mean,
Hadoop for sure. It's like, I got Hadoop on like my 500 megabytes of data. Yeah.
Right.
Yeah.
It's like 3 blocks, not even 3 blocks of HDFS. So
yeah. Don't get me started about when I was a consultant and people used to be like, yeah, we're doing big data. Here's the spreadsheet of the big data. And I'd be like, oh, honey, no, that's not big data.
Yeah. Oh, interesting.
Here's a question going back to your academic background. The scale of astronomy you were working at, or astrophysics actually, do you feel like it was kind of big data scale, or was it sort of small data more?
Yeah, I mean, it's interesting because when I started in the early days of Redshift and Tableau, doing that paradigm of, having data readily accessible, curated in Redshift, and then using Tableau on top of it, I remember being like, man, I would have finished my PhD so much faster if I had this. Because I do think that, like, I used to sit around waiting for programs to run all the time. And I would start a program, go home, come back the next morning, fingers crossed it was done or it hadn't died, right? And, it's probably dating me a lot because it was pre-cloud. But Matt, you were there,
Yes.
And so I definitely think that there's a lot of overlap. And I think that doing observational astrophysics really prepared me well for being a data engineer and working with data engineers, because it's we keep improving, slowly we're improving the telescopes that we're using. And so we're getting more and more data, and it's not the variability and the velocity of like streaming or something, but it's still like the basic concepts are the same, and really defining like, the math behind what you're seeing, like forces you to almost model the data and really think about what you're going to present to the user. And so going from that large scale of having a huge data set down to like, here are the numbers that actually matter, and align well with the math behind it. I mean, I think there's definitely a parallel in business there as well, because that's what you're really doing in Tableau or any BI tool, is trying to distill all of this data down to the KPIs that are going to help you move your business forward, right? So it's actually really similar, except we also use calculus.
True. And differential equations occasionally, representation
yeah.
theory. Yeah. I feel like what I'll say, obviously I'm not like in academia day to day to know all of what's going on, but it does feel like academia is way behind in terms of adopting some of these more modern data tools, just like you're saying.
Yeah.
I don't know. I mean, part of what I'd like to do is maybe give back to the science and academic side by getting people onto modern tools, because it is a huge opportunity for science to move faster too. So for example, one of my friends went to UT Austin. He did astrophysics simulations, and his data, his output is stored on tapes, which means that if anyone wants to like look at his data and like repeat the experiments, they have to request the tapes. It's like, wait, why aren't we adopting object storage in, you know, academic supercomputing and other things so that we can collaborate just like business does?
I know, it's ridiculous. I mean, it's cost. It's largely cost, right?
Yeah.
I will say though, in a box in my basement, in the room right below me, there is a giant set of like probably 40 or 50 tapes from Keck Telescope in Hawaii from my dissertation. They're exabyte tapes that have no way of reading them. I asked my advisor, do you want these? And she was like, what are they? And I like explained it. And she was like, no, we don't need those. And I was like, I guess they'll just sit in my basement then. And my husband keeps being like, do we really need these? I'm like, yes, because they're the only copy that we might have.
So wait, are they actually exabytes of data, or is that just the?
No, it's the brand.
Okay, that's what I was wondering.
Oh, okay. I was like, on a tape. That's crazy.
No. So this was pre the idea of an exabyte of data actually being a conceptual thing. It was like so far off that, you know, it's like Ternary Data, right?
Right, exactly.
Yeah.
How much data do you suppose is actually there? Are we talking a petabyte? Are we talking like 100 terabytes?
It's not even that much. It's not that much.
Interesting.
I don't think. And the thing is, it's a lot of like when you do astro on a Earth-based telescope, you end up having to take like a lot of calibration images to subtract out the sky and stuff like that. So it's a lot of that too. It's a lot of like, you know, processing data. It's not like the actual data, but without it, you can't get clean data. So
yeah, that totally makes sense.
Yeah.
It's interesting. But yeah, I think about that. I'm like, what if PhD students were able to just put all that stuff in object storage so that others can say, hey, here it is. It's published. You can look at my data. Just go to this S3 bucket.
I know. And I mean, there are certain free resources. Like you could spin up a demo account on Starburst Galaxy and use Galaxy to use your data. And then you could, you know, use a free S3 bucket and try to get some. But I mean, that's not a long-term solution.
Right.
So,
right.
Yeah.
That's pretty fun.
Yeah.
Actually, Milan, he says he's a data nerd and haven't listened to this part, pun intended. And incidentally enough, Milan, he's going to be on the show on September 2nd, so next Friday.
Awesome.
So I chatted with him the other day. Really highly smart guy. You should talk to him. He's cool.
I will.
So,
Very cool.
Awesome. Well, cool. Wrapping up. I actually got to go sell my house right now, so I got to go jet. So
sure, why not?
I mean, you know, just
as you do.
Yeah. That'll be a lot of fun. You want to talk about something as backwards as title companies and going there and signing papers. Wow. I can't believe this industry exists.
Yeah, they could use some modernization.
Well, title insurance too is the weirdest thing, right? So it's like you throw this hubbub with title and it's supposed to be secure, but then you got title insurance on top of this in case they make a mistake. Right. And so it's like WTF.
That sounds like a scam.
I think this is what John Malthus was talking about with economics, like
the Malthusian trap,
the Malthusian trap.
Yeah. Well, let's talk about that on another show.
It's all over the place.
Data Malthusian traps.
Yeah, exactly.
No, but it's a crazy industry, and it's like, when I look at this, like, okay, this is where blockchain could actually have an application and stuff like title. Like, why doesn't this exist? Instead, I got to go spend the next hour filling out forms, and that's super fun. So.
You seem really excited. I'm really happy for you.
Thank you. Yes. Yeah. Well, when I get that
you're
check,
excited
then I'll
to be
be happy.
selling your house, but not the process.
Not this one. It's another one. So. But cool. I feel like we could keep talking for hours. And well, maybe if we go get a beer or something in Boston, then we will. But
or Salt Lake if you ever get here. So.
Yeah.
Chance we'll go to Boston.
We'll be to Boston.
We'll see which happens first. But I'd love to. Yeah.
That's awesome. By the way, I'm going to be in New York City this week. So if anyone in the audience is in New York, hit me up. LinkedIn message is probably the best way to do it. So, but yeah. And again, next Monday, I don't think we're having a Monday morning data chat. Matt and I might surprise you and we might just show up and just randomly do one unannounced, except it'll be at the same time and same place as always. So it's not really a surprise, but it's more like we might be flaky. We might not be. So, but next Friday, Milan is on, and we got a great roster of guests coming up in September. So anyway, fun chat. Glad to have you on. For people who want to learn more about you or your book or about Starburst, how can they do that?
I'm on LinkedIn. I'm on Twitter. I don't really tweet that much. Probably more prolific on LinkedIn, or just Colleen at starburst.io.
Cool. Awesome. Well, thanks for being on. Thanks to the audience. Great questions. Yeah, really good interactions.
Yeah, this has been super fun. Thank you.
Yeah, awesome. Cool. All right. Have a good day. Bye.
Bye.